Hey everybody, welcome to today's video. Today we're going to be looking at a scenario that I think all of us have faced at some point, which is spreadsheet like the one that you see on the right. And whether you're using Excel or Google Sheets, I think we've all seen at some point a large extract from a database, hundreds of rows, thousands of rows, lots of interconnections between the data. And then I think we've all had that experience. You analyze it, you package it, you put it into some nice presentation. And then always what happens is 2 days later, your boss calls you with just some simple question. Could you just remind me, what was the total revenue for that department or for this geography? You have to go back and you have to go through all of the report again, basically to just retrieve that one number then that your boss needs, either text it to her or send instant message because they need that number for board meeting or presentation. And so what we're actually going to show is how you can start automating some of this using generative AI securely, safely, cost effectively, and accurately to start asking natural language questions to spreadsheets just like this. All right, so to do this, we are going to use the Model HQ SQL bot. When we launch into this bot actually comes packaged with 3 sample spreadsheets, including the one we were just looking at. That's the sales workload 2. So we're going to look at that type of operational data. We're going to look at a simple customer table that we mocked up. And then the third, we're going to look at some financial data on the S&P 500 companies. These are just standard CSV files, but they are structured like database schema because they actually were extracts that came from a database. Again, a lot of the spreadsheets that we get every day that you ultimately have to do some analysis around. So there's no other prep that we're going to do here. What's going to happen as soon as I push action is we're going to begin to open up those files. They're going to be parsed. A schema is going to be inferred both from the column structure and the attributes then of the values in each of those columns. And then we're going to pull all that information and save it into a local database inside Model HQ so that all of the analysis and everything will actually be running on our local device. So let's go ahead and let's get started. All right, the spreadsheet that we're just looking at had 7,600 rows. So we've been able to infer a schema because it was a pretty well-structured table. And now we're actually copying all those rows into our local database. And it'll take maybe 1.5 to 2 minutes to get through all this, but I wanted to show it live so that you can see this isn't something that takes hours or days, doesn't require any customization, it doesn't even require any technical support. Standard CSV, like one that you probably have hundreds of, and in the course of a few minutes, we're actually converting and saving it on a local database. The benefit then of having it in a local database is then we can begin to start to use SQL to query it. And we're actually going to use a specialized SQL agent that we've built that's included in Model HQ. We're going to ask natural language questions. That's going to get converted to SQL. The SQL query is going to be run against our local database, and then we're going to get the answer back. And the whole end-to-end life cycle of it, completely no code, completely private. There's no token charges. There's no risk of data leakage. There's also no risk that as you're experimenting or learning or asking good questions or bad questions, that it's going to be tying up enterprise data resources or risking any kind of security or contamination of an enterprise data resource because all this information ultimately is being copied and being queried against on a local machine. So we're done with the 7,600 rows. We're now going through the second, which is 500 rows. And the third one was really small, the customer table. So we've already gone ahead and created that table. So now we're loading our SQL agent and we're setting up our SQL bot. In about 2 minutes, we are up and running. And what we're going to load then as a source are those tables. So the first one that we're going to look at is the financial data. And when we've loaded it as a source, just a simple way to think about it is we're going to ask a question to that source. In this case, that source is this database table that we just created with the S&P 500. One thing that I would encourage you to look at is the source information. Just like if you're learning to do prompting or searching, there's usually good best practices associated. One of the best practices associated with querying database tables is look at the language that the database table understands, and that's the schema. The schema is ultimately the vocabulary that database speaks in. And so understanding what some of these attributes are and using some of these names or keeping some of these names closer in the way that you're framing your query is definitely going to lead to better results. So let's go ahead and we'll just run through a few sample queries just so you can get a sense of how this works. So this is a list of the S&P 500. We're going to say just list the top 10 companies ranked by highest revenue growth. There, we've got our answer back. And again, remember the source of this information. This was not pulled from the web. This was not pulled from some model's, memory that may or may not be accurate. This is grounded 100% in the source information that we provided that's been loaded in a database table. There is no risk of hallucination. The risk is that the model may have trouble converting our natural language, list the top 10 companies ranked by revenue growth. It may misinterpret. And the way to assess if it's been misinterpreted, if you are a little bit technical, is you can start to eyeball the SQL query that we provide. So you can try to do a test. Does that query look like what my question was or not? The worst thing that's going to happen is it may retrieve the wrong information from the database, or it may come back with a null result saying it just wasn't able to really understand what you were saying. But there is no risk of anything happening to your data because we're working off a data copy. So we've gotten our first question. Let me just do a second one, and then we'll move on to the next data source. All right, we looked at the list of the highest revenue growth. Now we just want to get some basic information about the company with the highest market cap. All right, not surprising, that is Microsoft. You will note, short name, that's kind of a weird way to say this. Why did I pick that? Well, I picked that because I was looking at the database schema. And the way the database schema was set up, there's a short name and there's a long name. And so because I was looking at that, I wanted to frame my query in a way that would lead it most likely to the language that the database understood. All right, so those are just a couple of questions on our first data set. Let's move on to the next one. And so the next one that we'll look at is just our customer table. And as I said, this was a really, really small customer table. In fact, it might be saying too much to even call it a customer table. So let's just ask a really basic question. Just list all the customers that are in it. And you can see a list. It's around 20, 25 customer names that we've built just in this mock-up of a customer table. And now that we have all the customer names, we could say, what is the All right, cool. So we were able to pull up, got a list of all of our customers, and then we wanted to start just asking some questions about some of the attributes associated with those customers. You might imagine just having this running in the background all day. And as you have some question about a key data attribute, you can ask a quick question and immediately get the answer to. It might be helpful for that question that you get from your boss saying, could you just remind me again, how much is Martha spending with us? Or what was that information about that store? Now you actually have a really easy way to go get that. All right, and finally, let's actually go to the example that we started with, which was looking at our largest table, which was all that operational data on our different stores across different countries. So let's say that we wanted to find out how many different countries we're in, and we really wanted to get the turnover for all of those. Cool. So this gives us a view. And again, you'll note I picked turnover. Again, perhaps more of a European word than American way, which is say the revenue. But I noticed what this SQL schema was, and I thought that I would get a better result trying to keep the phrasing closer to what that schema is. And then we'll ask one more question. All right, again, cool. We get a view of all of our departments. And so now what you can see in less than 10 minutes, we created 3 database tables. We loaded them into our local database. We loaded our SQL agent, all of this running entirely locally, no token charges, no risk of data leakage. And we're able to start engaging in natural language queries across all 3 of these data sources. And you saw the whole process end to end, everything that went into actually enabling this to run. But now one question that you might ask is, all right, that's really cool, but none of this is my data. How do I get my data into this process? So it's really simple. What we're going to do is we're going to open up our SQL bot template. And now instead of running it, we're going to go to editing it. And when we edit it, what we really want to edit, we like all the parameters of it. It was actually working pretty well. If we're seeing that it is not working well for our data, there's a whole bunch of other parameters that we can go quickly edit, all with no code, do some experimentation and iteration with. But in this case, all we really want is, yeah, there we go. Those are the 3 sample files that are provided. But how do we start adding our own files into this template? And what we're going to do is we're just going to add another CSV to this. You could add 10 more. You could add 50 more. we're just going to add one. And it's as simple as pulling a CSV. Like we started, you probably have them sitting in a folder and many folders on your local machine. These should be database table-like things where there is a well-defined column structure, where you have lots of rows with common sets of attributes. So there is error handling, some triage capability. It will intelligently be loaded into a database. But if it doesn't follow any type of structure, it's going to be difficult actually to get really good responses using SQL. But if you have those types of pseudo database CSVs, and it's as simple as we're going to go on our local machine, and here we go. We have an SAP extract, and the file type, it is a table. So we don't want to just extract text from that. We actually want to try to infer that it is a table structure. And we've just added it. So now we're going to save and exit. We can actually look, and you can see right there, our table file that we just added has been added. And now we could go ahead and we could run. So the first thing that's happening is that spreadsheet we just added, our custom spreadsheet, the database table is being created. The others don't have to be created because we've already done that. And then we go through the exact same process of loading our agent, setting up our SQL bot, and then we'll just close by showing, there we go. That was the database table that we had just loaded, and now it is available so that we can start asking natural language queries against it using our schema as a guide to the kinds of questions that we would want to ask. And we could go ahead and we could keep repeating this process, adding spreadsheets, asking natural language to them, point and click, absolutely with no code. Again, no token charges, all of it running safely and securely on your local device. Hope that you've enjoyed today's video. Again, this is a pretty exciting area around natural language querying of structured data. Stay tuned for lots more to come. Thanks, everyone.